Oh no!
Assalamualaikum and hi. We are from Group 1 of MCTE 3373 and going to present our system named IoT Weather Monitoring System.
What is IoT? IoT is a network of interconnected computing devices, mechanical and digital machinery items, animals and people with unique identifiers, which is UIDs, and the ability to send data over a network without requiring human to human or human to computer interaction. The thing in IoT can be either a smartphone, smart TV, vacuum bot, heart monitor pacer, built-in automobile sensors. IoT have the real-time interface by using smartphones or smart screens. Fast, precise and user-friendly are how we can describe IoT benefits towards our life and the industry.
The idea of our project came from the problem of the weather is unpredictable, as we are not evolved to predict the future events of our day. Sometimes the students in Mahala, are too busy with their assignments, quizzes and projects to bother drying our laundry at the clothes hanger. Mahala hostels does not provide any roof to protect the clothes from the heavy and unpredictable rain. They are often forgetful because their main focus is only on their studies and lectures. Thus, device or a system is needed to sense the weather condition to inform them that it will rain or not on that particular day.
Based on the problem statement stated before, our group has come to a decision by implementing a weather monitoring system with the application of IoT. The main purpose of the system is to monitor the current weather situation by displaying a few features to the user, including the temperature, pressure, altitude, light and humidity located at Mahala's clothes hanger. So basically, the system will be implemented at the Mahala drying area. Next, for the IoT platform that we use is called Blink. Blink is basically a platform that allows us to control Arduino, Raspberry Pi, and other devices via the internet using either iOS and Android applications. The reason why we choose Blink is that it is a free open source available for both iOS and Android, and it also makes it easy to create a graphical interface for our IoT project by just dragging and dropping the widgets. Besides, users can receive notifications when using our weather monitoring system, since Blink provides the approach to deliver the push notifications that pops up on a mobile device. Thus, the user can check on the current weather situation whenever and wherever they are just by looking through the Blink app downloaded on their smartphones. There are 5 components and sensors involved that we use in this system. That are first, Nodemco ESP32, second, THT11, third, BMP180, the next one is BH1750, and the last but not least, SSD1306 OLED, where it is an organic light emitting diode display sensor.
The mechanism for this project is relatively straightforward. First, the device will turn on when the power is supplied to the USB. Then, the system will go through some setup processes such as connecting to the Wi-Fi network and to the Blink. After that, all the sensors and output devices will be initialized to make them ready to be used. For every second, the sensor reading such as temperature, humidity, light intensity and pressure will be taken and output to the OLED display. At the same time, the reading will be pushed to the Blink server. The user with the Blink app installed on their phone can view the real-time sensor reading from anywhere around the world. The light intensity value is used to determine the sign of rain. The rain detection is triggered when the value goes lower than 10 lux, which indicates cloudy or overcast. After that, the user will get notified via the Telegram app to know that it is time to pick up clothes from the drying place.
Here is the PLC diagram. We actually aren't quite sure how to make the PLC diagram for our system, but we managed to come up with this simple PLC diagram. First of all, input 1 refers to a power supply. In our case, our power supply is the USB that is connected to a laptop's USB port. So when we plug in the USB port, all outputs, which are the BH1750, which is a light intensity sensor, BHT11, temperature and humidity sensor, BMP180, a pressure sensor, and SSD1306, which is an OLED, will be turned on. From there, all readings will be collected and updated to our Blink clouds. Next, as you can see at rung number 3, there is an output named sensor reading. That is basically indicates that all of the data will be displayed on the SSD1306 OLED. Then, at rung number 4, we use a comparator, which is the LES, that will compare the reading of the light intensity sensor to the value of 10. If the value of the light intensity sensor is less than 10, there will be a reminder or a notification that will pop up on our specified Telegram account, telling us that we need to pick our clothes off the drying place, since we are assuming light intensity less than 10, as either it is going to rain or it is already in the night time.
In conclusion, we successfully created and proposed an IoT weather monitoring system that can be implemented at the Mahala. The system is a setup that will monitor the light intensity, temperature, humidity, and hence, it will help the students' clothes from getting wet by the heavy rain, increase their productivity, and save lots of time from rewashing their laundry again.
And that's how IoT helps us.